Hi, thank you for watching this video on script parsing with hierarchical sequence modeling. I'm Škrjanec, and this is joint work with Fangzhou Zhai and Alexander Koller. Let's start with some background. Script knowledge is a category of common sense knowledge about how people perform simple everyday activities. It encompasses participants that are involved in each event of this activity and the order of these events. A good command of script knowledge has been shown useful for various downstream NLP tasks. A crucial step for exploitation of script knowledge is script parsing, which is the task of aligning surface text with predefined classes of events and participants. Here's an example. Based on our human script knowledge, we know that the activity of repairing a flat bicycle tire includes a bike rider, a bike, tools, and a tire. These participants are involved in the events of riding a bike, noticing the tire is flat, getting tools, fixing the tire, and then finally checking if it holds. Events and participants are typically realized by content words, most notably by verbs and nouns. The script parser should process an entire document and then tag the verb and noun heads. For combinational models in practice, this is a difficult task. For example, the verb found describes two different events in the story. The model should consider the basic local semantics of the verb as well as its position within the text. We use a hierarchical model to handle this. Another challenge is data sparsity. The corpora annotated for script knowledge are limited in size because they're quite expensive to create. To alleviate this, we experiment with domain adaptation and data augmentation. We use two English corpora in our work. InScript contains stories about these 10 everyday activities or scenarios. And the second corpus we used is Descript, which contains process descriptions of the same 10 scenarios. InScript is our main corpus, while Descript serves as auxiliary training data. Both datasets are annotated for events, but InScript is additionally annotated for participants. It should be noted that each scenario has its own set of labels. Given the optionality, we distinguish between regular events and participants, which are crucial to the respective scenario. And then in contrast, irregular events and participants occur in the activity but are optional. Most events in InScript are irregular, while in Descript the majority is regular. The 10 scenarios vary in complexity, which is also reflected in the class sizes of events and participants. Our task is to parse the input text and tag nouns and verbs with corresponding event and participant classes. We propose a hierarchical model that operates on two levels: word sequence and event sequence. The word sequence model encodes the entire input story using the XLNet pre-trained encoder. At the index selection step, we keep only the vector representations of tokens that are heads of noun and verb phrases, while we ignore the rest of the input. The selected representations are passed to the event sequence model, which is a BioSTM. Its output is passed to a linear output layer. Our efforts to address the data sparsity issues are twofold. First, we tried two methods of domain adaptation. In the first one, it's just a simple concatenation of the InScript and Descript training sets. Secondly, we also do explicit domain modeling with corpus embeddings. The corpus embedding is a trainable parameter which is concatenated with the XLNet representations. We also augmented the data with paraphrasing. We back-translated the InScript training data to French and back, and then concatenated the back translations with the original InScript dataset. We compared a hierarchical model against three baselines. We used the CRF-based script parser from Ostermann et al., which is the state-of-the-art model. Our second baseline is a linear classifier with a fine-tuned XLNet. And our third baseline is just like the hierarchical model, but we do not select the indices of noun and verb phrases, but rather use the entire input sequence. Here, the micro and macro F1 scores for event and participant parsing. In terms of event parsing, all proposed models outperform the state-of-the-art model by Ostermann by a considerable margin. The hierarchical model, so the model that performs index selection, improves over the model with no index selection. For the models with domain adaptation, the corpus embedding approach seems to be a slightly better way to exploit Descript than the data concatenation approach. Compared to the hierarchical model that uses in-script only, the model that is additionally trained on back translations sees a large improvement. However, further addition of descript on top of this model generally leads to a small drop in performance. The most common prediction error is tagging an event or participant as irregular when in fact it's one of the regular ones. Due to the complexity of the task, the inter-annotator agreement is quite modest, and indeed some errors in the model occur due to noisy corpus labels. There's also a small number of events that are tagged as participants and vice versa, for example in case of homonyms of verbs and nouns. In conclusion, we present the first model that achieves high performance on both event and participant parsing. We show that exploitation of domain adaptation and data augmentation yields a substantial performance boost. In the future, we would like to employ less supervision to lift the requirement of finely annotated data and enable wide coverage script parsing. Here's the link to our code and data. Thank you for your attention, and we hope to see you at the poster session.